Examples. Find the nth term of the sequence. Solution. We have 4, 5, 8, 13, then 23 dots. Now looking at this sequence, we can see, checking the difference first, 5 minus 4, we have 1, 8 minus 5, that is the third term minus second term, that's 3. 13 minus 8, that's the fourth term minus third term, that is 5. And fifth term minus fourth term, that is 7. So in this case, we can see that the differences we have here, they are not the same. So this is like the first difference. The first difference. Now, we need to check out the second difference also. Second difference, 3 minus 1, what are we going to have? That's 2. And also, 5 minus 3, we also have 2. 7 minus 5, we also have 2. We can see that the second differences are the same, while the first differences are not the same. Meaning that this kind of sequence is a quadratic sequence. And looking at the first term here is 4. And we need the first number here, which is 1. We also need this, which is 2. Now, 2 is equals to 2z. 2 equals to 2z, where our Tn is equals to what? X plus Yn plus Zn squared. So in this case, dividing both sides by 2, what do we have? 2 divided by 2 equals to 2z divided by 2. This implies that 2 here 1, 2 here 1. 2 here 1, 2 here 1. So z equals to 1. Z is 1. And the next stage for the first difference, we have this to be equals to y plus 3z. It means that y plus 3z equals to 1. Since we know the value of z to be equals to 1, the value of z is 1. So this implies that anywhere we see z, we put 1. We have y plus 3 into what? Into 1 equals to 1. So from here we have y plus 3, that is 3 times 1, we have 3, equals to 1. Y equals to 1 minus 3, and that is minus 2. Now, we need to get the value of x. Here, this 4 represent what? This 4 we have here represent x plus y plus z. That's the first term. X plus y plus z. So in this case, an x plus y plus z equals to what? Equals to 4. Anywhere we see x now, what are we going to do? Anywhere we see x, no, we are looking for x. So it means we substitute for y. Y equals to what? Minus 2. And what is z? Z equals to 1. So we look for x. X will be equals to what? 4. By the time you transfer minus 2 to the right, you have plus 2. Then plus 1 to the right, you have minus 1. So 4 plus 2, that is 6. 6 minus 1, that's 5. So we know the value of x to be equals to 5, the value of y to be equals to minus 2, and the value of z to be equals to 1. So we can now write the nth term of this quadratic sequence using what we have here. What is x? X equals to 5. So we now have 5, which is for this. Now we write plus yn. What is our y? Minus 2. Then we have n at the back. then plus zn square. Plus zn square. What is our z? Z is 1. So we have 1n square. So we can now write this as what? 5 minus 2n, 1n square, same thing as n square, plus n square. That is the n term of the quadratic sequence. Thank you.